I am Patirage. In our fraud detection project, we built 4 different models to check which one gives the best accuracy. In my part, I will explain the bidirectional LSTM, which gives the one of the highest accuracies. First, in here, I imported all the required libraries and deep learning layers such as LSTM, Dropout, and Dense. These are the tools we need to build our neural network. So next, I loaded the clean dataset, and it has around 15,000 rows and 39 columns. Uh, Next, I separated the dataset into two parts: X for all input features and Y for target column called fraud, which tells if a transaction is fraud or not. After that, I split the data 80% for training and 20% for testing. I also used a standard scaler to normalize numeric values, and this helps the model learn faster and more accurately. LSTM models need 3D input, so I reshape the data so that each transaction becomes one time step with 38 features. Now about the model. A bidirectional LSTM reads data both forward and backward directions, which help it understand patterns better. My model has two BILSTM layers, the first with 128 units and the second with 64 units. Between them, I added dropout layers to reduce overfitting. Finally, I used dense layer with ReLU activation and one output neuron with sigmoid activation. After training, the model achieved about 95% accuracy with 93% precision and 98% recall. Finally, I visualized the model's performance using accuracy and loss graph. Both the training and validation lines are close to each other, which means the model is well trained or not overfitting. So overall, the BILST model gives excellent result and help us detect fraud more accurately. Thank you.
This is the implementation of DNN model. The first step is for importing libraries. It loads all necessary Python packages. And the second step is for loading the clean dataset. It reads the preprocessed CSV file. In here, we prepare data for training. It separates features from target variables. Then it splits train data and test data. 80% for train, 20% for test. And the next step is feature scaling. It standardizes all features to mean and standard deviation using standard scaler. In here we build the DNN model. It creates the neural network architecture with 4 hidden layers. Next we compile the model. And here we set up callbacks. Early step into prevent overfitting and reduce learning rate when plateau. And the next step we train the model. It runs the actual training process, feeds data through the network, calculates errors and updates weights. In this step, we evaluate the model. Test the trained model on unseen data and calculates performance matrices. In here, we generate a classification report. It generates a detailed breakdown showing precision, recall, F1 score for both normal and fraud clauses. And the next step is for confusion matrix visualization. It creates a heat map showing true positives, true negatives, false positives and false negatives. And here this is for ROC curve. It plots the trade-off between true positive rate and false positive rate at different thresholds. And this training history visualization, It plots accuracy, loss precision, recall all training epochs. Then save the trained model, and at last it generates the summary report. It prints a comprehensive summary of architecture, training configure, and final performance.
But I will explain the LSTM model, which also give a high accuracy in detecting fraud transaction. First, I import the required libraries such as NumPy, Pandas, and deep learning tools from the TensorFlow like LSTM, Dense, Dropout, and the Adam Optimizer. These were used to build and train our neural network. Then I loaded the clean dataset. I contains about 15,000 transaction record and the 39 features like transaction amount, country, bank, time, and card type. Next, I separate the data into X and Y. X included all input features and Y include only the fraud columns, which is the target that shows in the transaction is the fraud or genuine. I divided the dataset using 80 by 20 train test split and using the standard scaler to normalize the data. Scaling helps the model to train faster and improves accuracy. Now I built the LSTM model. One LSTM layer with 64 units to learn sequential pattern, dropout layer to prevent overfitting, a dense layer with ReLU activation, and finally an output layer with sigmoid activation and classify fraud or not. Unlike BILSTM, this LSTM model reads the data only one direction from past to future, which make it simpler and faster. I train model for 20 epoch and I achieve 95% accuracy, 94% precision, and 96% recall, which means performance well identified transaction will keeping false alarms low. I also plotted the accuracy and loss graph. Both training and validation curves are stable, showing and the model learning well without overfitting. Overall, the LSTM model is simpler and faster BILSTM and still performs very well, making effective for fraud detection. Thank you.
Hi, I am Chamodya. I built a CNN model to detect credit card fraud. First, I imported all the important Python libraries that I will be using in this project. Pandas and NumPy are for working with data. Seaborn and Matplotlib are for visualization. Scikit-learn is for splitting the dataset and evaluating the model. And TensorFlow KS is for building and training my CNN model. First, I loaded the clean CSV file using Pandas. After loading the data, I checked the shapes of dataset to see how many rows and columns it contained. This helped me understand the size of dataset before I start building the model. In here, we can see the columns and their data types. In these steps, I separate the dataset into two parts, features and labels. X contain all the columns except the fraud column. Y only contain the fraud column, which is the target or label for prediction. In this step, I change all numeric data into numbers. Boolean values become 1 and 0. Text value were converted to numbers. This is important because the model can only understand numbers. In this step, I split my dataset into training and testing part. 80% of data goes for training and 20% for testing. strain and Y-train are used to train the model. Xtext and Y-text are used to check how well the data model performs. In here, I reshaped my training and testing data to fit the CNN model. I added one extra dimension using this because CNN needs 3D input sample features and channels. Then I built my CNN model. The first two one-dimensional convolution layers learn patterns from the data. The max pooling layer reduces the size and keep the important part. The flattened layer turns the data into a vector. The dense layers make the final prediction. The last layer uses a sigmoid activation to predict fraud or not fraud. I complete the model with Adams Optimizer. This is the result of that code. I trained the model using the training data. I use 20 epochs and the batch size is 32. In here, I used the test data to evaluate the model. I calculated several performance metrics. This is the result. Accuracy is 96.03. These results show that the CNN model performed well in detecting fraud with high accuracy and reliability. This is the conclusion matrix. The model correctly predicted most of the transactions. 1,489 normal and 1,392 fraud. Only a few were wrong. 72 false positive and 47 false negative. This shows the model is performing really well. We can see the result clearly using these graphs. Thank you.